morning, guys. I hope your break was well. So, I am going to be showing you how to do evaluating some trig functions in the coordinate plane. All right, so I have this picture here of just to show you how the angles will be shown in the coordinate plane. Okay, so if you think of like a clock, you have like an initial side and a terminal side. Well, actually, don't think of a clock because both hands move. So you can think of it like this side is just staying put, and then this red side is called the terminal side. That could rotate in the plane, right? So if you're here, you're at 0 degrees. Here, you will go up to 90 degrees, and then you go to 180 degrees, and then you go to 360 degrees, right? Which would make the whole circle. Okay? For the most part right now, we're going to be just going in the positive direction, okay? Is actually counterclockwise. If you ever needed to measure negatively, you could go clockwise is the negative direction. So down 90 degrees, 80 degrees, 270, 360. All right, so we're going to be talking about the quadrants today and when the angles fall in certain quadrants. Okay, so here, if you remember, this is quadrant 1, this is quadrant 2, quadrant 3, quadrant 4. Okay, so I can have an angle that's up here in quadrant 1. I can have an angle that's over here in quadrant 2. I can have an angle down here in quadrant 3, 4, and so on. Okay, so let me show you how to do it. We'll use the reference angles. So here's the first problem. When the angle theta, right, theta just means some angle, is in standard position in an xy coordinate plane, the terminal side of the angle lies in quadrant 1, okay? Terminal side just meaning this red side, right, would be in quadrant 1. So it's going to be an angle over here, okay? So if the terminal side lies in quadrant 1, okay, if the sine of theta is 3/5, what is the tangent of theta? So I drew my little coordinate plane here, right? So it said that the angle falls in quadrant 1. So that means that I have some angle right here, okay? Here's the angle theta. This is called the reference angle, okay? If I had something in quadrant 2, the angle would be here, okay? That would be your reference angle, okay? We'll get more into that. But, okay, so I'm in quadrant 1, okay? And it says that the sine of theta is 3/5. And they want to know what is the tangent of theta. So, the sine of theta. So, here's an angle. So, what I'm going to do is I can make a right triangle. The way you make it, you always connect the right triangle with the x-axis, and you could just make a right triangle right there. If I'm over here in quadrant 2, I could connect this right here, and I'd have my angle here right there. If I had an angle in quadrant 3, right, I would connect it with, again, always connect with your x-axis, and there would be a triangle there. All right, so right now, I'm in quadrant 1. Okay, I'm just use that to show you how you'd make the triangles. Is this blurry? It's like a little blurry, right? All right, so that's better. Okay, so the sine is 3/5. So I'm going to take this triangle here, opposite over hypotenuse, right? So that means this here is 3, this here is 5, right? So I want to determine what is the tangent, okay? So I need to find this missing leg. So I could use the Pythagorean theorem. Okay, or if you noticed, this is a special 3, 4, 5 triangle, right? If you didn't know that, you would use the Pythagorean theorem, right? So if I didn't have this here, I would do 3 squared plus b squared equals 5 squared, right? So that's 9 plus b squared equals 25. B squared equals 16, so b is 4, right? So this is b. So if you have to use the Pythagorean theorem, use the Pythagorean theorem, which sometimes, most of the time, you will have to, unless you know the triangle. All right, so how do I know what the tangent is? Now that I have all the legs, I can find the tangent. What is the tangent? Well, the tangent of theta is opposite over adjacent. So my tangent is going to be 3/4. Okay? Why am I even bothering using the quadrants? Because you might just think, well, I could have just drew the triangle and found the tangent, right? But it depends on the quadrant. Is going to depend if it's positive or negative, right? Because if I'm in this quadrant 1, all my x's, right, are positive and my y's are positive, right? So both of these values would be positive. If I'm over here in quadrant 2, this would be a negative value for x, right? X is going in the negative direction and y is positive, right? And here we would have x would be negative and y would be negative, right? And if I had a triangle in this quadrant, my x is positive, right, over in this direction, and this leg here would be down in the negative direction, right? So there's actually a way to determine that. It's A, S, T, C. So this stands for, well, this is like a little helpful. All students take calculus. That's how you could remember it. What this means is that in quadrant 1, all of the trig functions are positive. In this quadrant, only the sine functions are positive. Okay? In this one, only tangent is positive, and in this quadrant, only cosine is positive. Okay? Why is it? Because look, if I have a triangle over here, why is only the sine positive? Because first of all, this distance is always positive, okay? Because it's distance, it's not from your x coordinates. All right, but the sine is opposite over hypotenuse, right? And this is in the positive direction, right? This y is positive over hypotenuse, so you're going to have positive over positive. It's always going to be positive sine. Why is my cosine negative here? Because I would have a negative value here over hypotenuse, right? Because it's adjacent over hypotenuse, and this adjacent x here is going to be in the negative direction, so that's why it's going to be negative in this quadrant. All right, so that works in every quadrant, and this is just a little helpful way to remember what's positive where. All right, so if I'm in this quadrant, my sine and my cosecant, because that's the reciprocal of sine, is going to be positive, and every other function, cosine, tangent, cotangent, secant, they're all going to be negative if you're in quadrant 2. So that's why it matters what quadrant you're in, because it will affect if you're positive or negative. All right. I guess I could do one more with you just to make sure. Let me just draw. Give me a sec. Let me just draw another little. So here's one more problem. Then I'm going to give you some of these to practice. Suppose that theta is a second quadrant angle and the cosine is -4/5. What is the value of sine theta to the nearest tenth? Okay. So this time it says it's a second quadrant angle. So I'm over here in second quadrant. Okay. Here's theta. This is your reference angle. The angle goes like this, right? But you're going to just use this little reference angle. Okay. Make the triangle with the x-axis. Okay. And what did it say? It said that my cosine of theta is -4/5. And we want to find the sine of theta. So -4, my cosine is adjacent, is here. -4, that makes sense. When you're talking about distance, you're always talking about positive, but if you're referring to inside the coordinate plane, you're going to determine that this is going in the negative direction, okay? And over hypotenuse is 5. This one we were always going to be a positive, okay? It's a distance, always positive. All right, so again, this is your other little 3, 4, 5 triangle. Since this is going up here in quadrant 2, this is in the positive direction, okay? So that stays as a positive. Okay, so my sine is opposite over hypotenuse, so my sine is going to be +3/5, okay? Okay, just like I told you here in the second quadrant, sine's always positive. So you can use this to check your answers to make sure you're correct. All right, so I'm going to be putting up some of these practice problems. Let me know if you have any questions. Have a great day.